All right, welcome to lecture 23, part B. In this part, we're going to talk about how pressure relates to other properties of a gas. So specifically in this part, we're going to look at how pressure of a gas relates to the volume of a gas. So how does pressure relate to how big a sample of a gas is? It could be like a balloon or any sample of a gas. The person who figured out this relationship, by the way, was a guy by the name of Boyle. So this is going to be called Boyles Law. So he figured out when you change the pressure of a gas, what happens to the volume of the gas. All right, so to start off with, I'm gonna show you a little video that has to do with this relationship, and then we're gonna get into the math of it. There's kind of an equation that goes along with it. So let's go ahead and get to it. Let me flip over here. Okay, so to start off with, I'm going to show you a little demonstration, a little video. And in this video, we're going to see what happens to the size of a gas when we change the pressure. So the gas in this case, like a sample of a gas would be like, for example, a balloon. So that's a sample of a gas. So what happens to the volume of this balloon when we change the pressure? So let me go ahead and start it. And what's going to happen is they're going to turn on a pump, and that's going to make the pressure go down. And when the pressure goes down, let's see what happens to our balloon. When the pressure goes down, the volume of the balloon, you can see it's getting bigger. All right, so when the pressure goes down, the volume goes up. Oh, we should write that down. All right, let me pause it. I'll write it on the screen here. So what we're seeing so far is when pressure decreases, that's what they're doing right now, volume increases. The balloon got bigger. Now, in this clip, let me kind of go ahead and continue it. Now what you're going to see happen is they're going to make the pressure go back up. They basically turn off the pump. So when the pressure goes back up, let's see, when the pressure goes back up, the balloon gets smaller again. So again, it's doing opposite. So when the pressure goes up, oh, pause that. When the pressure went up, the balloon got smaller. Pressure increases. Volume of the balloon, volume decreases. All right. So there's one more little just kind of fun thing in this video I'm going to show you. So another example of a gas, it's not just balloons, right? If you buy like a peep or a marshmallow, it's just a bunch of air, really, air and sugar. So you can do the same thing with a peep, all right? So let's put a peep in. Let's make the pressure go down. And when the pressure goes down, our sample of a gas, which is this peep, the peep gets bigger. Whoa, I feel like I got more for my money. All right, so there you go. All right, so in both cases with the balloon and with the peep, you can see, yeah, pressure goes down, volume goes up. So in math, there's a way we can say that. When things do opposites, that's called being inversely related. These ideas are inversely related. Now, we can even do better than that. Instead of just saying they're inversely related, we can actually come up with an equation that relates these two. And actually, the person who came up with this equation is a guy by the name of Boyle. So this is called Boyles Law. And he figured out, that's law there, he came up with this equation. P1 times V1 equals P2 times V2. So what does this mean? Well, the ones are like your initial conditions, and the twos are like your new conditions, your final conditions. So what this means is the beginning pressure times the beginning volume, P1 times V1, will always equal a new pressure times a new volume. So when you change the pressure, we can use this to figure out what's going to happen to the size of this gas, a balloon or a peep or whatever it will be. All right, so with that, let's go ahead and let's do a little actual math example now of using Boyle's law. When one goes up, pressure goes up, volume goes down, and vice versa. Okay, let's do an example. So let's see here. So it says a balloon has a volume of 2.5 liters at 750 torr. if the pressure falls to 120 torr, what will be the new volume of the balloon? All right, so let's see what's going on in this question. So first off, it sounds like the pressure is changing. So it doesn't really say pressure, but when I see the unit torr, yeah, that's got to be a pressure, right? So we're starting off at a pressure of 750 torr, and then it's changing to 120 torr, and I want to know the new volume. So if we're changing pressure and we want to know what happens to the volume, that's what Boyle's law is all about. Let's write it out. Okay. Now, we're going to have to do a little algebra, but before we even get to that, we got to figure out where all these numbers go. All right, so first off, let's just go back and read the question. A balloon has a volume of 2.5 liters. The 2.5, that's going to be V1 at 750 torr. So again, it doesn't say that's a pressure, but whenever I see the unit torr, that's got to be a pressure. So that's going to be my P1. So we'll put this in over here. So 750 torr. I put those liters in parentheses, no particular reason. All right. All right. Now on the right-hand side, that's going to be our new condition. So our beginning conditions we already have. Our new conditions, if we read the question, it says if the pressure falls to 120 torr, so that's our new pressure, I want to know what will be the new volume. All right, so I think we have everything in the right spot. Now what we're going to do next, we got to do a little algebra. So I got to get V2 all by itself. So when you have to get V2 by itself, what that really means is you got to move the 120 torr over to the other side. So it says 120 torr times V, so we're going to do the opposite. In other words, if we divide by 120, the opposite of multiplying, I mean, then what will happen is the 120 will cancel out, and we'll get this. My new volume for this balloon will be 750 torr times 2.5 liters divided by 120. All right, so you should type in your calculator. If you do it right, let me check my notes here. You're going to get V2 equals, when you do the 750 times the 2.5 divided by 120, it works out to 16. All right, now let's be careful. Let's not lose those good habits, right? 16, we got to have a unit on there. So the units, let's see, torr will cancel. The unit we're left with is liters. So make sure you write down the unit. Don't forget that. And then the other thing that we want to double check is, you always want to double check that your answer makes sense. So let's see what's gone on here. If we read the question, we've changed the pressure from 750 to 120. The pressure has gone down. 750 to 120. As you saw in that little demonstration video, when the pressure goes down, the volume should be going up. Did that happen? Does that look right? I think so, right? So we started off at 2.5 liters and went up to 16 liters. So yeah, the pressure of the volume went up. All right, let's do another example. We'll do another one. All right, Boyles Law, P1 V1 equals P2 V2. Let's see if we can get this, make sure we have this figured out. Let's do another one. All right, let me flip over and we'll try another one. All right, I gotta flip the slide here. All right, another example. All right, let's make sure we got this figured out. Okay, so this one, it says a balloon, so a sample of a gas really, has a volume of 725 milliliters at 3.25 atm. So atm is shorthand for atmospheres. That's a unit of pressure. All right, so we know this balloon is at 725 milliliters and it's at 3.25 atmospheres. If the volume changes to 435 milliliters, what's going to be the new pressure? All right, so this question, they're talking about pressure and volume. Got to use Boyle's law. All right, so let's put it up and let's see if we can figure it out. All right, again, maybe you can help me a little bit with this. Okay, so A balloon has a volume of 725 milliliters. That is going to be my initial pressure, volume, I should say. A volume of 725 milliliters. I'm going to put that in for V1 at 3.25 atmospheres. That's going to be my P1. All right. Now, let's keep on reading. We just keep reading the question. Well, it's got to figure out where these numbers go, right? If the volume changes, oh, so we got a new volume. If the volume changes to 435 milliliters, that means that V2 is going to be 435. What is the new pressure? So the final conditions, the new pressure, that's P2. We're solving for P2. All right, so hopefully that looks right. I think it does, right? We got our initial conditions on one side. We got our new conditions on the other side. We don't know the new pressure. We're going to solve for that. So to solve, all right, this is where I'm going to see if you can figure it out. What would you do to solve for P2? You should divide by 435. All right, does that look right? Yeah, you got to divide by 435. Oh, why? Because you need 435 to cancel out. Then when that happens, you're going to get P2 equals this. 3.25 times 435 divided by, times 725 divided by 435. All right. So go ahead and type that in your calculator. Let's make sure you got the math right. And, why don't you tell me the answer? What do you come up with? And make sure you round it. Okay, if you typed in your calculator correctly, the right answer should be, and this is rounded, 5.42. And, we got to have units on there too, right? The milliliters cancels, would be in atmospheres. All right, so make sure you show your work. Make sure you round your answers and have units on those answers. And then also make sure it makes sense, right? So let's just double check that last part. Does it make sense? Well, let's see. The volume in this case is going from 725 down to 435. So if the volume is going down, what should happen to the pressure? The pressure should be going up, right? So the pressure should be going up. So it's starting off at 3.25 and it went up to 5.52. So that sounds right. Yeah, if one goes down, the other one goes up. All right, let's do one last one. So this one again, I'm just going to put up and I'll let you work on. We'll see how it goes for you. I hope okay. So let's try one more. All right, a little multiple choice question. A flask with a volume of 500 milliliters of a gas is sealed at the top of Mount Everest, where the pressure is 230 torr. So 230 torr, that's pretty low. Like at the top of mountains, the pressure tends to be lower. Okay. If the volume of the gas, what is the volume of the gas when the bottle is moved to sea level? Okay. So at sea level, just so you know, most likely the pressure would be like normal pressure. It would be like 760 torr. So it doesn't quite say that, but if we're talking about like in Ventura at sea level, the new pressure would be probably 760 torr. All right, so with that little hint, let's see if you can figure it out. Oh, maybe I'll give another hint. V1, P1, P2. What is V2? All right, work it out. Let's see how it goes. Okay, hopefully they got that right. Hopefully it makes sense. If not, we're going to practice this during our Zoom time. You can come and ask me questions or send me an email, and I'll try to help you out. All right, so with that, there's one more part to this lecture we're going to work on, and that is what happens when you change the temperature. All right, so that'll be in the last section. Let's move on to that.